Hi, this is Jonathan Hart, and this is going to be the first video in a series of videos about design patterns. So, in this first video, we're going to look at where software projects commonly go wrong, and I'm going to call this the anti-pattern. Um, so most mistakes are made not in the first version of software, but in subsequent versions where after the product has been delivered, the client's satisfied with the product and then the business grows and expands and they want to bolt on additional functionality. A lot of times you no longer have the original developers or the original vision in-house anymore, and so then new developers come in with lack of vision and lack of clarity on the entire object model, and so then things start to go askew. So let's say, for example, our sample business is going to deal with cars and trucks. And so, version 1 of the software, they are dealing solely with cars and trucks for whatever their business purposes are. So, we would have two objects, a car and a truck. And let's give them a common functionality, say to go. So we would say public void go. And all this is going to do, I'm going to put a console statement here. This would normally be a longer implementation than a one-liner. But like I said, all of my sample implementations are just going to be console statements just to keep it simple. So we'll say, look, Ma, I'm driving. And we'll do the same thing in the truck. Anybody familiar with object-oriented design would say this is a mistake. You've got two different objects with the same implementations. We should not do this. We should use inheritance. And that's usually what you would do. So you would create an abstract class, we'll call it vehicle. In an abstract class, you cannot actually create a vehicle. An abstract class has to be inherited into a subclass. So you make your car and truck inherit from vehicle, and then anything that we define in the abstract class automatically gets sucked into the car or the truck, and we can use it. So if we put this here and get rid of these implementations, uh, that will work. So now here in our main application, we can create a car. We would say new car and a new truck. And then you can make them go. You'd say car.go and truck.go. Okay. Now what we would expect to see when we run this is the console should come up and say, look, Ma, I'm driving twice. That's exactly what it does. Um, Now to see what's actually going on under the hood, notice that go is actually not defined in the car or the truck. It's calling this implementation in the abstract class. So if we set a breakpoint here, here, and we actually watch what's occurring, you'll see that it goes here to the abstract class, executes go, and then the same thing from the truck, it goes and it calls the exact same implementation. Even though you're dealing with a car object and a truck object, it pulls this implementation. So you see, look, Ma, I'm driving. So both cars and trucks effectively go with the same implementation. And that's what's delivered, and the client's really happy. And then a year later, the business expands, and they say, okay, well, we've done so well with cars and trucks, let's do airplanes. So you say public class airplane. And this is where it starts to get tricky. Because an airplane doesn't drive. I mean, you could drive your airplane, but you wouldn't really want to do that. Um, Something about fitting on the road would be a problem. So if we say airplane.go, We don't want our airplane to drive, we would like it to fly. And of course you see the airplane is driving and that's wrong. And this is where the mistake is made because you say, okay, well, most of the time when you've got an existing object model and you want to add a new model that's somewhat related but maybe does one thing different, you would like to perhaps override it. So you make the abstract implementation virtual, and then you come down here and you say public override go, and then you would say, look Ma, I'm flying. And that fixes it. And they say, okay, now we want to do helicopters. So again, it's another type of aircraft. And once again, vehicle is limited in its usability. Now we can't reuse it because it's an aircraft and we never factored in aircraft into our base vehicle class. So now the option is maybe I can refactor these guys and have a separate abstract class called aircraft with their own go method. Except for the fact the problem is helicopter doesn't really fly, we just want it to hover. So that's no good. So then it becomes sufficient to just do another override and this time we'll say I'm hovering. And that builds and runs. So let me just add him down here. And so now we've got cars driving, airplanes flying, and helicopter hovering. And then for the final piece of the puzzle, we'll go back and say that now we deal with multiple types of airplanes. We're also dealing with jets, which are known to fly, except these guys fly really fast. So once again, you go back and you override your abstract go method. You say a little bit of humor there, Top Gun reference. So then we come and we use the jet, hopefully without caps lock. So then when we say jet.go, we run, and we've got our jet implementation. So in the next video, I'll show you how to use the strategy pattern and how to detangle this object model that has gone completely askew.